Welcome to question number 28. In this question we have limit of x to the power of 3 minus a to the power of 3 over square root of x minus square root of a as x approaches a. Now the mistake that many students make is just substitute the value of x for a. If we do so, what will we get? We have a to the power of 3 minus a to the power of 3, which will give us a numerator of 0, and we have square root of a minus square root of a, which will give us a denominator of 0. So this is not the right answer for this question. So what do we have to do? We have to play with the expressions that we have over here to see what is another way of writing them, so it will enable us to simplify. As we do so, we will get to the right answer, and after that we will be able to substitute the x for a. So what is another way of writing this expression? Is a minus x, x minus a, so it's x minus a times x squared plus ax plus a squared. So this is another way of writing this expression, and this is all over square root of x minus square root of a. So what is another way of writing this expression, x minus a? So we can put it we can give that the values of x square root of x minus square root of a, so that we can simplify with this denominator. So another way to write the expression of x minus a and not change its value is by writing it as square root of x minus square root of a times square root of x plus square root of a. By doing so, because as you can see, the first number multiplies the first number and the second number of the other parenthesis, and the second number multiplies both numbers of the other parenthesis, and this will give us x minus a. So it means that the value of this expression is not changed. So this is another way we can write it, and we did it so that we can simplify with the denominator. And what is the rest? We have x squared plus ax plus a squared, and that is all over to square root of x minus square root of a. So this and this can be simplified. Now as we simplify it, it will be very easy, because all we have to do now is, instead of x, put the value of a. So we have square root of a plus square root of a times a squared plus a times a plus a squared. And what do we have here? We have 2 square root of a times, we have a squared, we have a times a gives us a squared plus another a squared, so we have 3a squared, and this is all equal to 6a squared square root of a. As you can see, this is the process you need to follow to get to the right answer. Welcome to question number 29. In this question we have fx, which is equal to 2 plus x squared minus x minus 1 to the power of 3, and all this to the power of 2, and we are as the derivative of f2. But before we find the value of derivative f2, we have to first find the derivative of fx. So let's see what it is equal to. So we have derivative of fx. Now what is the logic here when we are dealing with derivatives? Now as you see, within the parentheses we have x as a factor. So as long as we have x as a factor, we can deal with the parentheses. So first we deal with the big parentheses, and after that we move to the smaller parentheses. So we take 2 in front, because we are dealing with the derivative of fx, and we have 2 times 2 plus x squared minus x minus 1 to the power of 3. And what do we have here? 2 minus 1. Why? Because one of the 2's, we took it and we put it in the front. Now what do? We still deal with this parenthesis now. So you can see that 2 doesn't have an x factor. Therefore 2 will become 0. And what do we have here? We have 3 times x squared minus x minus 1 to the power of 3 minus 1. Why? One of the 3's, we took it in the front, therefore we have 3 minus 1 times, now let's take care of these parentheses because we have x here as a factor, so there is x here. So 2 goes in the front, so we have 2 times x, so here is 2 minus 1 minus x So here power is 1, so we leave 1 in the front. X to the power of 0, because 1 minus 1 is 0, it's 1. So it remains 1. So because 1 minus 1 times 1, it's minus 1. And 1 doesn't have x as a factor, therefore it becomes 0. So what do we have here? We just have 2x minus 1. Now that we found the derivative of fx, all we have to do is just substitute 2 for x. So we find the derivative of f2. Now all we have to do is substitute 2 for x. So we have 2 times 2 plus 2 squared minus 2 minus 1 to the power of 3 all to the power of 1, which doesn't have to be written. So we have 3 times 2 to the power of 2 minus 2 minus 1 to the power of 2 times 2 to the power 2 times 2 minus 1. So what do we have here? We have 2 times, we have 2 to the power of 2 is 4 minus 2 is 2 minus 1 is 1, 1 to the power of 3 is 1, plus 2 is 3. So we have 3 times, we have 4 minus 2 is 2 minus 1 is 1, 1 to the power of 2 is 1, 1 times 3 it's 3, and we have here 2 times 2 is 4 minus 1 is 3. So we have 2 times 3 times 3 times 3, and the value of derivative of f2 is equal to 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So the final answer and the correct answer for this question is 54. So this is the process you need to follow to get to the right answer. So what you do, first we found the derivative of fx, and after that all we did was just substituted 2 for x, and that's it. Greetings everyone, and welcome to question number 30. In this question we have, if x is greater than 0, we are given fx, which is equal to x to the power of 2 plus 1, and we are asked the inverse of fx, to find the derivative of the inverse of fx for 2. Now what do we do here? We first have to find the inverse of fx, after that find the derivative of the inverse of fx, and after that all we have to do is substitute 2 for x, and we will get to the right answer. So let's try to find first the inverse of fx. How do we find that? So we have fx, which is equal to x squared plus 1. In order for us to be able to find the inverse of fx, the first step is to try to leave this x alone on one side. So it means that we have fx minus 1, which is equal to x squared. And now we take the square root for both sides. So we have square root of fx minus 1, which is equal to square root of x to the power of 2. So here the power of 2 cancels the square root, so we have square root of fx minus 1, which is equal to x. And now we just substitute we substitute fx with x. So the inverse of fx is equal to the square root of x minus 1. Now, as we found the inverse of fx, we will try to find the derivative of the inverse of fx. So we have the inverse of fx, and now we are trying to find the derivative of the inverse of fx. So what is another way of writing the square root of x minus 1? Another way of writing this expression is x minus 1 to the power of 1 over 2. So how do we find the derivative of in this case of this function? It's we take the power in front of the parentheses, because as you can see here we have x as a factor. So we put 1 over 2 times x minus 1, and now what is left there, 1 over 2 minus 1 over 2, it's minus 1 over 2. What is another way of writing this expression? So we have 1, because we try to make this exponent a positive exponent. So we have 1 over 2 times x minus 1 to the power of 1 over 2. So the derivative of the inverse of fx is equal to 1 over 2 times x minus 1 to the power 1 over 2. And what is left now is just to substitute x with 2. So we have the inverse of the derivative of the inverse of fx, but now we are trying to find for 2, which is equal to 1. 2 times 2 minus 1 to the power of 1 over 2, so which is equal to 1 over 2 times 1, so the final answer is 1 over 2. As you can see, this is the process you need to follow to get to the right answer. It's just a short summary. What we did here, we first found the inverse of fx, after that we found the derivative of the inverse of fx, and all we did after that was just substitute x with 2, and we got to the final answer.